Okay, are we live? I think we are live now. I hope so. Yes, it looks like we are. Hello and welcome to another episode of GameHammer Live Game Coding. So, in this program, what we do is we try and make a text adventure game. We've been making it for quite a few weeks now. I've got all of my notes right here, and the idea is very simple. We're making a text adventure game on the Amstrad CPC live on YouTube week by week. It's one of those fun situations. I hope we are actually live on my channel. I'm just going to quickly check on my YouTube page and make sure that we are actually live right now, because I have a horrible feeling that it's going to mess up. So let's have a look at my channel. Sorry guys, we're just doing a quick check basically. Looks... Am I just don't know. I hope we are. Anyway, let's get straight into it either way. Yes, I am live, apparently, according to Jenny. Thank you very much, Jenny. We are live. It doesn't tell... I've got a green light, but that just tells me the camera's on. I have no other signals. So, let's just get straight into this, shall we? Okay. Let's do the three-fingered salute. Control, Shift, Escape. There we go. Let's have a quick look here. Hello, Yellow Belly. Greetings to you too. Load episode 1. This is, of course, the Arbiter episode 1. And here we go. Now, last week we had a situation where we got the majority of what I wanted to do done. We spent a lot of time putting together the image for what is going to be a logic puzzle that requires a little bit of work on the part of the player. So let's get straight into the game and have a look through and make sure we are set up to start working. So we'll go down, we get the multi-tool, get core. So we've got the multi-tool and the core. Let's leave the ship, go up east and out. All of this is, I'm so happy the way it's working. Search wreckage. We're going to put a load of, once all of the logic puzzles and other bits are in, I'm going to go back and put in a lot of atmosphere so you'll be able to examine things, faff about with other things, basically make sure that this world feels like a living world. Hi Patrick, nice to see you. I'm so sorry with what happened with your channel, Patrick. That's ridiculous. I'll tell you that there should be a lifetime ban from YouTube for anyone who makes unwarranted, false accusations and copyright claims. That's my view, and I'm really sorry with what's happened to you, Patrick. I hope it all gets sorted out. So we've got the crowbar. Go west. Use multi-tool on wires. Paired the wires. Go west again. Use multi-tool on wires. Okay. Use crowbar on hatch. Go down. Get junk. Drop junk. Put core in housing, because of course we can say that instead of use. Okay. Look. And exam wall. Fault indicator saying that computer core error light is blinking red. Main internal door indicator lights are shining green, so everything's working. Go up. So we're now in a situation where we go north and we are in the computer room. So let's save there and we'll call it the file name test. So we're not going to be changing too much at the moment. One machine in the center of the room still appeared to be intact. So exam machine. I could not see a machine. That's what we're going to be setting up today. Exam circuit, I think it was. And there we are. There's the circuit we spent ages sorting out last time. So there are some cosmetic things I want to change on that, but for the moment we're going to do all right. So we've saved here. Just make sure we have save test. There we are. Look. And let's get straight into it. The circuit on screen check is at 12,100. So pen 3. Let's switch to that. List 12100 to 13000. That sounds so familiar from last week. We've got a load of object positions, and so the positions are inventory of -9, -10, -11, and -12. Yes. So we need to be able to put things into those. And then we had one thing in there. So the first thing I want to do is edit 12240. Pen 3. And then print. Because I don't want the circuit and the text about the resistance to be... They're different, basically. Okay. Save episode 1. So that's nice, and that's sorted out an issue that we had. So we've got the... We don't need to worry about that. So the other thing I want to do is examine machine. Was it machine? Oh, I really wish I could scroll back up. Let's list the places. The room data. List 252 2000. Where is the bit about the room data for the computer room? The computer room is room 4, so it won't be too far. One machine in the center of the room still prepared to be into. So we need to examine machine and get some information for examine machine. Okay, so where's the examine code? 10,050. I have all of the parts of the code written out, so I know where they are. 10,050 to 10120, which is where the inventory code starts. So let's have a look. Where can we add this in? We can add it in pretty much anywhere we want. Let's add it in at 10056. If left string a string comma 5. No. We're going to add this in later. Yeah, let's have a look. Let's put it in at 10091. If B string equals machine or B string equals computer, and current room percent equals 4. So if we're saying examine machine or examine computer and we're in the computer room, I want it to print a certain thing. Then pen 3 print. If you hear tapping and drilling and banging and knocking and sawing, that's because my wife Jennifer is just above us in her train loft, basically. And she's building a model railway layout. You can have a look at that on her own page. Jennifer's in the chat room now, so you can see her channel. She's building this massive loft model railway. It's really cool. Go and have a look at that. But that's why we get banging, thumping, drilling and stuff like that. Okay, so if we're looking at the machine or the computer, then let's put a description on screen that will direct the player to the circuit board. Hi Novabug. that will direct the player to the circuit board that they need to examine to be able to sort out this logic puzzle. Right, pen 3, print, blah, 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 blah. Okay, what should we say? The machine was charred, but still seemed able to function. A panel had fallen off the side of the machine, exposing a circuit if, and here's the flag, what flag have we got set for this? Computer fault. Okay, if flags percent 5 equals 0, then we need a semicolon there. If flags 5 0 equals 0, then print the circuit appeared damaged. Oh, we can't do that. One 0092. If B string equals machine, or B string equals computer and current room percent equals 4, then print the circuit, the exposed and then if sorry, I need to do quick. Flags percent 5 equals 0, then print the exposed circuit. No, this won't work. This will not work. Go to 10093. 10093 and copy all of what we just printed there. Exposed circuit. We'll come back to that. Edit 10092. We just need to keep it going. Else go to 10100. Edit 10093. The exposed circuit appeared to be damaged. The computer could not function correctly with this circuit in that state. Else print the exposed circuit was fixed and functioning correctly. Okay, that should sort this out. Episode 1. So are we going to try another politics podcast again? I enjoyed that last time. Yes, Novavog, at some point we can do that. Probably not tonight though. But yes, we should definitely set something up. And Novabug also says, sometimes the programming of a text adventure is better than the actual game. Well, as a fan of text adventures, which is why we're coding one here, I have to agree actually. Not all of them are great. I'm hoping this one will be fun, but we never know. This is my first one in years. I haven't made a text adventure since Wow, going back to the early to mid 90s. So yeah, I'm hoping this is a fun one. Okay, we haven't changed anything in terms of the information in the game, so let's just load it in the save game and make sure this works. File name is test. We should be yeah, in the computer room. Exam computer. Type mismatch in one. Edit 10092. Oh, current room percent equals 4. Okay, well, we got somewhere there. Save episode 1. Run again when it comes up. Come on, come on, come on. There we are, run. And actually, we will save it on Java CPC as well, because otherwise we'll lose all our progress. So let's load. The file name is test. Takes a minute to load in everything. At least we're not on Commodore 64. We'd still be loading in from the first time. Just a quick dig at Commodore 64. Lovely machine, but the marketing department at Commodore made a very big mistake in saying that they had to use that damaged VIC-20 disk drive ROM just to maintain compatibility. The engineers should have stood their ground and said, screw compatibility, we want a disk drive that loads at the right speed. Okay, so exam machine. Machine was charred and the exposed circuit, there it is. Exam computer. Machine was charred, the exposed circuit, there goes south. Exam machine. The machine was charred, it's not supposed to work. Exam computer. Could not see a computer, so examine. There we are. So, it's working kind of, but we need to make some changes. List 10090 to 1001010 even. I see the problem. At line 10,091 we have if B string equals machine or B string equals computer and current roaming percent equals 4. And we've done that in 10,000. Oops, sorry. And we've done that in 10,092 as well, which basically means if the player types exam machine in any room, it will give this information. But if the user types exam computer, it will only print this if the current room is 4. So we have to edit those two lines because I got this wrong. If B string equals machine and current room percent equals 4. No, we need to take that space out. Okay. Edit 10092 if B string equals machine and current room percent equals 4. Right. So now both times if you type exam machine or exam computer, it has to be correct. You have to be in the right room. Excuse me. Notebook says if this is a good one and you can be able to add some graphics, submit it to RetroDev. I am considering that, Novabook. We will be considering that at some point, definitely. Right, we saved that. So drive div note save. What we have to 26k of adventure now. We're going to have to be careful because we only have 41k left to play with here. Patrick says he's working on a loading screen. That's brilliant news, Patrick. Thank you very much. Right, run. And we're going to try examining the machine. Let's just start the game first. Exam computer. Could not see a computer. Exam machine. Could not see a machine. Now we're getting somewhere. Load. Test. No, can't have test. Ah. Oh. There's an interesting bug, isn't it? If we type in the wrong file name, the game ends. That's a bug we'll have to sort out another time. We're busy at the moment. Let's load in the game. Test. Okay. Exam computer. James chart. Exposed circuit appeared to be damaged. The computer could not function correctly with this circuit in that state. I could not see a computer. Well, that's not good news, is it? She can see a computer. The arbiter is in the computer room. So we have another bug. Do we? Oh, of course we do. Edit 10092. Edit 10093. And functioning correctly. Go to 3180. We need to put that on both. 3180. We didn't send the player back to the what next prompt. Of course we didn't. We need to do that because otherwise we'll get I could not see X, Y, and Z because we've already dealt with that particular piece of information. So that is great. Catalog just saved. And now we will be working fine. So let's just quickly test that, make sure that we have done it right. L to load a save game. Test. Loaded. Exam computer. What now? Exam machine. Blah, blah, blah. What now? There we go. Edit 10093. Just one quick extra thing. Print. That's just a quick cosmetic thing to put a line between those two paragraphs. Right, what we're going to do now is give the character the ability to modify what is in the circuit board. So let's go back to the information we have available. So we're at circuit on the screen 12100 list 12100 to 13000. Right. Blah 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 blah. Okay, here we are. We need now 12250 print in position I could with the right tools I could change the in positions resistors in positions A, B and C in this circuit to try to get the circuit working again. Print 12260 print in position A was 4t equals 1, 2, and how many objects do we have again? What is the circuit for that? OBJ, and if OBJ POS T equals position A is -10, then print and it will be what is it? What is the thing that we're doing? I've forgotten. I've forgotten what the object code is. Because we don't save it and I haven't got it written down. Okay, we need to know what that is, so we'll come back to 12260 in a minute. List, blah, 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 blah. It is object. Of course it is, it's object string. Edit 12260. Then print object string, comma, t, comma, 2. Plus full stop. Next, T 12270 print. We do the same thing again, but I'll change that in a moment. Right. And it's not -10 now, is it? Object pos hasn't got a dollar. Oh yeah, it's supposed to have a percentage. Well spotted there, Yellow Belly. That should be a percent. And position B, that is inventory position -11. Edit 12260. Because then, yeah, that's an annoyance. 12280. Position C was -12, yeah. One, 2, 2, 9, 0, go to 3180. So list 1, 2, 100 to 13000. Blah 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 blah. Yes. Okay. This should work. So, but only the player will only get that extra information that we've just put in if the arbiter is holding or has access to the multi-tool. Except we've called it a multimeter, and that should be not multimeter, multi-tool, because there we are. Save episode 1. Anthony says he has all the equipment to start his ZX Spectrum coding. Wish him luck. Yes, good luck, Anthony. And do share the fruits of your labours with us, because I do want to see that. I like the Spectrum. It's a nice machine. It's not as good as the Amstrad CPC, haha, but it is a good machine. And it needs more love. Okay, let's run this game. And since we haven't changed any of the variables or the number of objects or anything, we can go straight to loading a file and test. Exam circuit. We get the information there. Current resistance across the circuit was 0 ohms. Failchild says, is this CPC basic? Yes, this is CPC locomotive basic. The built-in basic from the Amstrad CPC 464 right the way through to the Plus. Did I ever experience laser basic on CPC? No. I only experienced 2 forms of basic on the Amstrad. It was locomotive basic and turbo basic, which, give me 1 second, I will show you. Oh, I should not move around like that. I have broken my foot during the election, and yeah. High soft turbo basic. I should not be climbing around with a foot in the state it's in. Now, it came on 1 cassette, and it was very interesting. It's not entirely compatible with locomotive basic. As you might expect, High Soft's turbo basic I think it's compatible with other versions of Turbo Basic for other computers. And it comes with a nifty little manual, which is really short. It's how many pages? 26 pages. And that includes examples of programs to create with it, which appears to be Space Invaders. So that's pretty cool. Most of Turbo Basic is the same as you would expect with all basics, because it's trying to be Microsoft compatible, I suppose. And yeah, so of course there won't be an explanation of basic in the manual, just their differences, because it is trying to be standard basic and compatible with Microsoft to a certain extent. So it's just talking about all the ways you compile it and things like that. This might be actually worthwhile trying another, when we do maybe we do another game, try and do it in Turbo Basic and see if we can compile it. That might be interesting. So I'm going to put this back later. I'm just going to say but yeah, that's probably an interesting project for another live game coding. Right, let's get back to the game itself. So for some reason we are not seeing the bit that we just typed in about how you can use the multi-tool to change the contents of A, B and C. We need to be able to do that, but I want to make sure that we can get all the stuff that we need. So let's go down back through this ship until we get to the cardboard box. Exam box. So a small box made of cardboard, likely designed to hold small items. Box contained all these resistors. Get box. Took the cardboard box, north and north. Failed says, I wonder if anyone would watch a live coding of a C64 Petsky graphic adventure. I used to write them all the time with my best friend. Failed. The Commodore 64 has one of the largest of the 8-bit fan bases on YouTube. So I would say if you try and do a live coding on a C64, yes, there will be an audience and people will watch it. The C64 and the ZX Spectrum dwarf the audience for the Amstrad CPC. So we've got people here watching me type a basic text adventure. I absolutely expect a lot of people would be interested in that. My C64 programming videos get hardly any hits. I'm sorry to hear that. Are you talking to people in the right channels? Facebook and Twitter and things? Right, let's get back to this anyway. Save, because we've got the box in our hands now, haven't we? Inventory, multi-tool, crowbar, cardboard box, yes. Save, test. So, oops. Oh, that's interesting. Oh, of course, because it's only checking for the first 4 characters, so we can type whatever we want. Right, saved. So, we now need to work out what's going wrong. Examine code is 10050 to 10. Let's do that. I believe it's there, isn't it? No, because we're doing the other bit. List. Sorry, 12100 to 13000. We're not looking at the machine code bit. We're looking at the circuit code bits. Where? Blah, 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 blah. There we are. Right, I see why. Edit 12240. Simple mistake to make. We don't want to send the player back just yet. Save episode. We don't want to jump them back to the wrong part of the code. Okay, no premature sends back to what next? Save. Run. Okay, let's quickly test that. Load. Test. Okay, exam circuit. Because we're carrying the multimeter, yes. In position A was, in position B was, in position C was. That's interesting. We should have something in positions A, B and C. For for a start, the broken ones are in there, aren't they? Yes. Print obj POS of 15. Oops. Print obj POS percent 15 is minus 10. Of 16 is minus 11. And 17 is minus 12. So, we should have a burnt resistor, a charred resistor, and a fried resistor in those positions. So, why isn't it there? Print object string of 15,2, a burnt resistor. So, the code should work. 12100 to 13000. Why isn't it? Because we can't get the player to move anything out of there unless we know. Right, that's interesting. Let's take out those lens in 12260 to 12280. If object position percent %t is minus 10, print objects. I think that should work. Okay, run 12260, that should work. And it still can't do it. Print obj POS percent 15. Subscript out of range. That's why. Okay, save episode 1. And save to the drive. This should work. Why isn't it working? Why is it making me sad? File name test. Exam circuit. Syntax error 12260. What if I just change some things? Instead of this, print and compress all of this into one line. And take that out. Okay, for t equals 1 to obj percent, which is the amount of objects that we have, if object position of t is minus 10, then print in position A was plus object t, comma 2. No. So then we can add in, no, edit 12260. We don't need another for next loop if we do it this way. Edit 12270, and this should speed the thing up. It won't change an awful lot in terms of what's going on, and we still have to work that out, but we can then delete a huge amount of code and get everything working quicker once we've got this sorted. Yeah, if object blah 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 blah, and now come back where copy all of this again. No, I don't copy all of this again. Yes. So now list 12260 to 13000. Yeah, 12290 gone. 12280 go to 3180. Okay, so we've compressed that. So now our for next loop only runs once, and that speeds the game up, reduces the amount of memory that we need because we've taken a couple of lines out, and hasn't solved anything basically. Yeah, this should be working. Why isn't it? Save episode 1. Okay, but we've compressed the information down, so hopefully we have removed the problem at some point. Run. Load. Test. Oh, come on, let's see. Please make this work. Exam circuit. Syntax error in 12260. What's wrong? Syntax error. I don't get it. Okay. Else, what? Yeah, I'm thinking we do need the lens statement, but I don't want it to do anything else. I don't want it to be doing, else t equals t. I don't want it to actually change anything, that's the thing. Edit 12270. So we do need this on separate lines because it's not going to work otherwise. Edit 12280. This annoys me because we shouldn't have to do this, but let's just do it. Make sure everything works. One two two 90 next. T go to 3180. Edit 12270. Isn't coding fun when things just don't work when they should work? Okay. Episode 1. I forgot what was that trying to code with 40-column text mode. Yeah, Electron Ash, you are correct there. It is so annoying sometimes. Right, save drive, save this. Right. Anybody know when that new Batman group driving game will be out as a demo to run? No, no one knows, basically. Electron Ash, is this on the CPC? Yes, this is an Amstrad. We are on Java CPC at the moment, emulating an Amstrad CPC 6128. Right, run. But this code will work on the CPC 464 and the Plus because we're just using Locomotive Basic. And we're not using any of the extended functions from Locomotive Basic 1.1. Hi, PCM Retro Gamer. I'm doing fine, thanks. How are you? Exam circuit. Please let this work. Why is it... there's nothing wrong with this. There's nothing wrong. Why? Oh, I've left the len out. There is something wrong. Then... save episode 1. There was something wrong. Load. Test. Hopefully this will work this time. We need this to work because I need the player to know what's in the positions. Otherwise it's not going to do it. Exam. We've been on this for 2 weeks. Yes! Yes! Oh, yes! It's working. It's working. Right. Okay. File, drives, save. So that is saved onto the hard drive. Oh my goodness. Electron Ash says retro collecting gets quite bad when you forget if you still own a 61. How can you forget if you own a 6128? They're wonderful machines. They should be burned into your memory as remembering that you have one. Okay. This is working now. So, we need to be able to get and put on, yeah. Okay, we need to be able to get things out of the circuit and put things into the circuit. So, okay, we need a quick look at the get code. The get code is at 10170. List 10170 to 10240. Where can we put some code here? There's not much space in the get code. Okay, 10221. If B string PCM Retro Gamer says, could this be converted over to the Speccy? Yes, it could. We're not using anything too different in Locomotive Basic to what's in Spectrum Basic. Most of the code here is proper Microsoft compatible. I'm not sure about the way we've handled the input command. And there would be an issue with screen resolution with the circuit board. But aside from that, I think you could fairly easily convert this over. So yeah, that would be a project for someone if they fancied it. That would be perfectly fine. Once this is finished, I'm going to make it available online for free. And you can fiddle with it if you want. There is a guy who's already said he wants to translate this into French for the French Amstrad community, which I'm perfectly fine with. So if someone wants to make a Spectrum port of this, then thank you for the vote of confidence in my coding. Go for it and have fun. Right. Oh, right. We need to make sure that we can do this. Okay, if C% is greater than, no, if C% is less than, no, hang on, if, what we need is if right string of B string, this is how we'll do it, equals from, edit 10221. I accidentally pressed from circuit, comma 1 2 3 4 5 6 7 8 9 10 11 12. Right, there's 2 4 6 12. Yeah, if right string B string, comma 12 equals from circuit, then go to 12200 else. Okay, list 12150 to 12200. Yeah. So we need to change 1. Edit 10221. We don't want it to go to that. 12210 else. Right. 12210. Just have to make it work to the right place. So this is get from circuit code. Okay. 12210. Okay. Okay. B string equals left string B string length of B string minus 12. So that now takes off the from circuit. So get x from circuit. Now we just have x left. That's what we want. 12220 for t equals 1 to obj percent if object string t comma 1 equals b string, then go to just b string and obj pos percent t equals minus 10. Yes. No. Equals b string. Go to 12230 else t equals t. 12230 if obj pos 12225 next t. 12230 if obj pos percent of, no, we do need that. 12230 if obj pos percent t equals minus 10, then obj pos percent t equals minus 1 because we're taking it from position A into the inventory. Print I took plus object percent t comma 1 plus from position A on the circuit using the multi-tool else. 12240. Change all of that. 11 from position B on the circuit using the multi-tool else 12250 position 12, and that's position C on the circuit using the multi-tool else 12260 next T. Yes. 12270 print. I could not see a plus lower string B string on the circuit, on the exposed circuit. Go to 3180. Yes. Edit 12230. T equals obj percent. Next T. I think we need to do all of that. Edit 12240. Yeah, we need all of that on the end there. Just to make sure all of this works and we finish at that point, I think. Go to 3180. We need that on the end as well. We'll get there in a moment. Okay, list 1221 to 122 12300. It's getting a bit warm in here, isn't it? Okay, we're going to put one quick check in. 12215 if integer POS percent of 1 equals -1, or obj POS percent 1 equals current room percent. Then go to 12220 else pen 3 print. I could not get anything from the circuit board without an appropriate tool. Go to 3180. Okay. Edit 12270 pen 3. Okay. Edit 12220 pen 3, just to make sure that it's all printed in the right color. Episode 1. Right, we should now be able to get stuff from the circuit, but we can't put anything onto the circuit just yet. So let's save that. Run. Okay, load. Test. Okay, we're carrying the multi-tool because our save game already has it. So exam circuit. One two two one zero. What have we done? What's wrong here? What's wrong with that? Have we just overwritten the wrong code? Oh my goodness, no, please tell me we haven't. Oh dear. We've just overwritten the code that we spent ages earlier in this stream getting right with the get code for next part. So load episode 1.back. List 122 12100 to 13000. Print circuit on screen. Okay, 1229s. Right, we're okay now. So 12300 is where we need to be. 12300 RAM get from circuit code. For some reason we put it in the wrong place. So, my goodness, I can't believe I did that. I can believe I did that. It's not the first time we've accidentally overwritten code. So we've got to write all of the get code again. So let's make sure that we have it right. The get code we need to jump out of into this bit is at 10170. List 10170. Can't believe that. Right. Start talking about housing units at right 10221 if right string of B string 12 equals from circuit, then go to 12300 else. One, two, three, 1, 0. Print. This is the get from kit code. Okay. Run. Let's hope this works and we're in the right position. Test. We just got to start that bit about getting stuff out of the circuit again. That's not a problem. Get D from circuit. This is the get from circuit code. Right, it's okay. Now we're working. So, list 13000 to 14000. List 12300 to 13000. This is the one. Save episode 1. Okay. Right, we're okay now. Let's save as we are. 12310. If current room percent less than or greater than 4, because that is the computer room, yes? Let's make sure we're in the right room. Yes. Then go to 12320 else pen. Actually, start with pen 3 so we don't have to keep typing that. Else print I could not see the circuit. Go to 3180. So if we're anywhere else in the game, then that will not work. 12320 if JPOS percent of 1, which is the multi-tool, equals -1, or JPOS percent, which is an object position of 1, the multi-tool equals current room percent, then go to 12330. Yes, else print I did not have the appropriate tool to alter the circuit. Go to 3180. Yes. 12330. Okay. B string equals left string B string length of B string minus 12. So B string equals only the part of what the player's type that doesn't include get and doesn't include from circuit. 1, 2, 3, 4, 0. For t equals 1 to up to j percent, which is the number of objects in the game. If object string t comma 1, which is the item command of each object, so for example multi-tool, circuit, battery, whatever, equals, no, if upper string object string t minus 1 equals b string and j pos percent t equals minus 10, yes, j pos percent of t equals minus 10, then print I took plus object string t comma 2 plus from position A on the circuit WJPOS percent of t equals minus 1. T equals j percent, because actually we don't need to do that, else 1, 2, 3, 5, 0. So we're just going to quickly do all of the checks that we needed to do before. T equals minus 11 this time, then print I took up blah 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 from position B on the circuit, else 1, 2, 3, 6, 0, and then for position C, one, 2, 3, 7, 0. Next, T, go to 3180. No, we don't want to say that, do we? Okay. Let's do this. If got it equals 1. Then go to 3180, else print I could not see a plus lower string B string on the circuit. Go to 3180. Okay. Edit 12320. Got it equals 0. One, 2, 3, 3, 0. No, edit 2, 3, 4, 0. Okay, here we are. From position A, got it equals 1. Got to do that one for all three. Edit 1, 2, 3, 5, 0. Got it equals 1. We did edit 1, 2, 3, 6, 0. Got it equals 1. Okay, that should work now. List 1, 2, 3, 0, 0 to 1, 3, 0, 0, 0. While that's scrolling through the list, let's save. Right, what we've done is quickly just made everything work. Yep, that should work. Okay, run. If this doesn't work, then we'll have to come back to it, but this should mean that we can get anything out of the circuit. Okay, exam circuit. Okay, that's an error that we fixed earlier on. It's okay. We fixed it and then sorted out. Forgot to save. Okay. Exam circuit. Okay, in position A was a burned resistor, in position B was a charred resistor, in position C was a fried resistor. Get bucket from circuit. I could not see the circuit, but we're in the right room, so we should be able to do that. Get burned resistor. Could not see a burned resistor. Get burned resistor from circuit. I could not see the circuit, but we're in the computer room. So what's wrong? List 1, 2, 3, 0, 0 to 1, 2, 3, 5, 0. Okay. If current room is less than or greater than 4, then go to 1, 2, 3, 2, 0. Else print I could not see the circuit. Print current room percent 4. We've got it the wrong way around, that's why. Edit 1, 2, 3, 1, 0. If current room equals 4, go to the next stage. Otherwise, say you couldn't see the circuit. Okay, we could have got anything out of that circuit from any room except where the circuit is, because I had the code the wrong way around. Well, this is why we test the game. Okay, let's save at this point. Hopefully this will work now. How big is our file now? 27k. We're getting somewhere. We're going to run out of memory at this rate. This is going to be a massive game, and probably might not be able to fit any graphics in it, which is a shame. Okay, loaded. Exam circuit. Okay, we've got the circuit and it's all working. Everything's there. Get bucket from circuit. I could not see a bucket on the circuit. Excellent. Extra space after bucket, but we'll deal with that in a moment. Get burned resistor from circuit. I could not see a burned resistor on the circuit. Oh. That's interesting. I could not see a resistor on the circuit. Right, we have a problem. Print object string 15,1 burned resistor. So why can't we see that? List 1, 2, 3, 1, 0 to 1, 3, 0, 0, 0. Okay, edit 1, 2, 3, 3, 0. I want to see where it's actually saying is B string at this point. Print B string. Let's run the file again from that. And what is it actually leaving us with? Test. Get burned resistor from circuit, because we know that's should be there. Burned resistor. I could not see a burned resistor on the circuit. Okay, that's not right. We should be able to see a burned resistor on the circuit. Why can't we? One, two, three, 7, 0. At this point, let's just take out that string because we don't that space even we don't need that. And 1, 2, 3, 3, 0. Let's take that bit I just added in about printing back out, because now we know that it is leaving behind what we need it to. So the code is correct up to that point. We need to now look at the rest. List 1, 2, 3, 3, 0 to 1, 3, 0, 0, 0. What have we got? What's wrong here? Okay. Upper string, object string, t comma 1 equals b string. So that if the uppercase version is equal to what we've typed in, and the position of that item is -10, which is position A, or -11, which is position B, or -12, which is position C, then we should take that thing out of there and put it into the inventory, which is position -1. All of that should work. So why doesn't it? I honestly don't know. I'm not sure why this isn't working. Unless it is. And we're not looking at it right. That's an interesting idea. What if it is and we just aren't setting the information properly? Let's load in test. Get burned resistor from circuit. I could not see a burned resistor on the circuit, but what's in our inventory? It has not moved it, so it really isn't finding. It really isn't finding this information. We've got an interesting situation here, because the code that we're using is basically the get code from the main game, and we know that that works because we've already done it, basically. What could we do? What are we doing wrong? This is an oddity. List 1, 2, 3, 0, 0 to 1, 3, 0, 0, 0. Edit 1, 2, 3, 4, 0. That is a comma, isn't it? Not a full stop. Yeah, it is. Well, that's how we would notice. It is right. So, if I don't see why this isn't working. Okay, let's try something else. If upper string object string 1 equals b string, then C% equals T. Next. T. If object position of C% equals -10, then print blah 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 blah. because we need to change all the T's to C percents now. 10% position A in the circuit, got equals 1, C percent else. Edit 12350. Send T to C percent. Take that out, actually, we don't need it anymore. Okay, we're just going to quickly alter a few things. This should work after this. If it doesn't, I'll be very surprised. Edit 12360. So we've done the for next loop earlier on. And now I just got the data that we needed, so we're just doing a series of other checks. This should work. I would hope it works anyway. C percent. Okay. Save episode 1. We don't need that next anymore. Save episode 1. Right, save on hard drive and run. This should now work. I don't see why it wouldn't work, because we've got everything set up the same way as we've got in the rest of the get code. Get biscuit from circuit. I could not see a biscuit on the circuit. Get burned resistor from circuit. I could not see a burned resistor on the... Print. Got it. Got it is still 0. Why? Why is it still 0? One, two, three. 4, 5. 1, 2, 3, 4, 5. Change. 2, 3, 4, 0. Just want this bit. Else T equals T. Take this bit out. Just trying to make this work. 1, 2, 3, 4, 1. Next T. I don't see why that would have made a difference, but let's just make everything easy on the brain. Test. Exam circuit. Let's remember what's actually in this thing. Burned resistor is in there because there is get burned resistor from circuit. I could not see a burned resistor. Why can't it see it? Why? I don't. But it's there. It's in position -10. Print object obj pos percent of 15, which is what's there. It's -10. So why print object string 15, 1 burned resistor. So what is wrong? What's wrong? I don't get it. I don't. Why is it... What's the code that prints could not find burned resistor? Hang on, is that what it's saying? The code that says could not print blah 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 on the circuit is at 12370. 12370 is where we say if we've already set the flag for got it to 1, just jump back to the what next. But if we haven't, then print I could not see a blah 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 on the circuit. And we're getting I could not see a blah 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 on the circuit when we try to get this thing. Which means that the code is not working from somewhere around 12340. But we know that got it equals 0. Got it. Edit 12320. Let's take that out of there. And add it to the line. We're not setting got it at all now, are we? Edit 12330. Got it equals. I'm going to set it to got it equals 2. Doesn't really matter what it's sent. Where is the if got it, then got it equals 1? It's in 1, 2, 3, 4, 5, 1, 2, 3, 5, 0, 1, 2, 3, 6, 0. If basically we set got it equals 1, whenever where we find it, whenever we find something in a position. So we are setting it, but I've set it to got it equals 2 this time because we're going to save now episode 1 because I want to make a quick check to see whether the code is actually being run or not. Let's have a quick look. Load then. So, if I type this in, if I type in the thing saying get burned resistor from circuit, okay, I could not see a burned resistor on the circuit. Electronash says, Yellow Belly says, shouldn't got it be got it %? Now here's the thing about Amstrad Basic, Yellow Belly. We don't have to tell it whether something's a string or an integer or anything like that. Percentage says it has to be a number, it can't be a string. But I don't have to tell it that if I don't want to. If I know that all that's going to be in there is numbers, I don't need to put a percentage on the end. It's just how it is. So, I could not see a burned resistor on the circuit. That's what we're getting, which means that the if check is being run at 12370, which is if got it equals 1, go to the what now prompt. If it doesn't equal 1, say I could not find a blah 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 on the circuit. So it thinks got it does not equals 1. Print got it. Got it is equal to 2. It has not changed it. That's the interesting thing. For me anyway. Pen 3. List 12300 to 13000. The code is not being triggered. It is not... So the I took X from position Y on the circuit is not being triggered at all. But we know that the burned resistor is in position -10. Because we know the burned resistor is object number 15. Because if I type in print object string 15,1, it says burned resistor. So if I print object position of 15, and it's -10, so it should know where this thing is. Print C%. C% is... There we are. That's why it's not being triggered. I just realised we're running a check on C%. Electronash, you've just got it as well. C% is not being changed. Why? Why is it not being changed? So we've got to look further. We've been looking at the wrong bit of the code. Well, at least I have. Electron Ash hasn't. He's found it. Where are we looking here? Okay, edit 12340. And here it is. For T% equals 1 to object percent. If object upper string object string T% equal, comma 1 equals B string, then C% equals T%, else T% equals T%. Next, T%. Save episode 1. So I'm going to set this to T% in case it doesn't work. In case that's what the issue has been. Let's load this in. Load test. Get burned resistor from circuit. No, 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 no. Print T%. T% is 18. Print C%. 0. It's never getting it. 12340. If statement isn't... Yeah, the if statement's not working. The upper string changes the... Electron Ash is saying, what does upper check for? Upper doesn't check for anything. Upper is a command in Locomotive Basic to turn the information that you're looking at into uppercase. Print upper string object string 15,1. Burned resistor. Print object string 15,1. Burned resistor. That's what it does. It just changes the string into uppercase. Oh man, why are we having so many problems? So that should work. Print B string. B string is burned resistor. So upper, yeah, B string is returning as uppercase burned resistor, which is what we've got in here. So, if upper string object string T%, 1 equals B string should work. If upper string object string 15,1 equals burned resistor, then print X, else print Y. X. So, if upper string object string 15,1 equals burned resistor, then print X, else print Y. I've just typed that in. That's not affected the code at all. That's just a piece of basic that I've just run. So I know from the fact that it printed X instead of Y that upper string check that upper string check should work, but it's not changing C%. Electron Ash says T% is 18 now. Yes, but that's because of the for next loop. And the for next loop is going from 1 to 18, because 18 is the number of objects in the game at the moment, and checking each one of those in turn. So it's starting at object string 1, 1 and going through to object string 18, 1 and doing the check each time. But we're only changing the content of C% on the one occasion where the two things are matched. Yes, Electron Ash. It loops through the object values until it finds a match for the right thing. Print obj%. Obj% is 17. So it's going through all of them. So I'm just going to add in it. Edit 12340. C% equals 0. We're just going to make sure that that's right. And that's set there. Print C%. Because C%, yeah. Third one. I'm going to edit 12340. Let's just change this, else C% equals C%. Let's not change what T is. C% equals C%. So basically, if we find this thing is the check that we want, then change C% to equal T%, else leave C% alone. Let's try that, instead of messing with what T% equals. Save as episode 1. Run. This... It's weird. Why isn't it doing this? Get burned resistor from circuit. I could not see a burned resistor on the circuit. Print C%. Print T%. 18. Edit 12340. Let's just take out the else. Run. I don't think this should change anything. Be amazed if it does, but let's just see how it goes. Come on, guys. What are you doing, Freddykins? My cat is attacking something. Fred, what are you doing? Are you just attacking a bag? You be careful now. Okay, get burned resistor from circuit. I could not see a burned resistor on the circuit. Exam circuit. Get charred resistor from circuit. I could not see a charred resistor. Get fried resistor from circuit. I cannot see a fried resistor. Yeah, we've taken... Okay, guys, everyone's suggesting that we take out the else. It's not changing anything. This is the odd thing. This puzzle has been an issue for us for 3 weeks now. It must be setting C% back to 0 after the check. Yeah, you'd think so, wouldn't you? But we're setting that before the 4 next loop, so it shouldn't be doing anything earlier. Okay, I'm gonna 1, 2, 3, 4, 0. We're gonna take out that C% equals 0 and put it on the line before. Edit 1, 2, 3, 3, 0, just in case. So we're putting C% equals 0. Right. Oh. Yeah, the thing immediately after the 4 next loop is just next. Right. For T% equals 1 to number of objects, if the uppercase version of object T%, 1 equals B string, then C percent equals T percent. Next T percent. And then all that's doing is finding the number. Why does it check for C percent minus numbers? Electron Ash, the C percent minus numbers, the next set of if checks, if the position of object C percent is equal to minus 10, then we know that it's in that object is in the location that we want. OBJ-POS is object position. It's the position of the object within the game. Room minus 10, basically, which is what we're using for the inventory numbers. So we need to know what this. They're minus numbers, Ash, because TVG has a very good point there. Throw some print statements within the loop to debug your values of T percent and C percent during the loop. Good idea. To answer your question, Ash, we're using minus numbers on the object positions because we don't want the object to turn up within the game. I don't want to be able to walk into room 10, for example, and find that there's a burnt resistor there, unless the player has put the burnt resistor into room 10. The player can't enter any room below room number 1. That's how the game was working. So having an object list in a negative numbered room means that it's somewhere that we can check in the code, but the player can never interact with it. That's why we're doing it. So let's do what TVGC77 has suggested and put some print commands into this for next loop. This appears to be the only way we're going to do this. For t equals 1 to print t equals T percent print C equals print C percent. Okay, run, load, save game, test. Get burned resistor from circuit. Right, so it's going from t equals 1 to t equals 17, and it appears to never be changed. Get burned resistor from circuit. Yeah, C is never changing, but T is going up from 1 to 17. Which means the for next loop is running and C is never changing, but we have looked at object 15. Okay, let's add in another thing. Edit 12340. C percent is not being set back to 0. No, the C percent is not being changed by this. It's never getting set, and that's the issue. So let's add in an extra thing. Print upper string object string T percent comma 1. Load. Test. Get burned resistor from circuit. Right, multi-tool, crowbar, wreckage, hatch, housing, junk, core. Red resistor, blue resistor, green resistor, yellow resistor. There's burned resistor at number 15. So, yes, TVGC77, we do want to print C% at the end when it gets changed. The problem that we have is I was checking to see if it ever changes during this. It hasn't got changed while we're going through this. We're not setting we're setting C% to T% on the check. That's our issue. We need to know why this isn't working. So we know that it's called burned resistor. Because if I type print B string now, that's what comes out. Burned resistor. That's what we're checking against. And we know that the if check will work because we've run it independently for this, and that's Electronash says maybe the if check isn't using T% correctly. It's got to be the only thing, because at this point that is the only thing that could be wrong. Surely. Edit 12340. I am using the value instead of the string, that is the thing. Upper string, object string, T%. Okay. T%, print T%. What is it at the moment? T% is 18. So if we set T% equals 15, print upper string, object. In fact, I'm just going to, instead of typing it in myself, in case I've got a check, an incorrect value somewhere, we're just going to copy it from there. Right, upper string, object string, T%, comma 1 is burned resistor when T% equals 15. So why isn't it working? Edit 12340. End if. Run. Load. Test. Get burned resistor from circuit. I could not see a burned resistor on the circuit. Are there possibly some spaces within the string being checked against? It's a possibility. Print full stop plus B string plus full stop. There is. You're correct. There you are. There you are, Ash. That's where it is. B string has a space on the end of it. Electronash, you have saved the day, because we've got something wrong earlier in the code. 12300 to 13000. Where is it? Edit 12330. B string equals length B string minus 13, because we didn't take the space off the front of from circuit. All I did was check for the last 12 characters, which means from space circuit. But that's not what we need. We need space from space circuit. Edit 123. It is sometimes the simplest things, isn't it? Okay, let's get rid of all these print statements. Oh, I am so glad you're all here, guys. Save. episode 1. If in doubt, print everything. Yes, but we did print everything. What we didn't do is put full stops in the front and back of everything to make sure that there weren't any spaces. Okay, we saved. I'll save again to the hard drive just to make sure. Load. Test. Get burned resistor from circuit. Syntax error, no! What's wrong now? Oh, end if is not a thing. So we don't need that. Run. There's always something, isn't there? We can't have a nice night where everything just works. There's always got to be a problem that stumps us for 3/4 of the entire stream. Get a burned resistor from circuit. I took a burned resistor from position A on the circuit. What's in our inventory? A multi-tool, a crowbar, a cardboard box, and a burned resistor. Exam circuit. In position B was a charred resistor. In position C was a fried resistor. Yeah, we've done it. We need to make sure that that it makes an indicator when we know what's in a position 1, 2, 1, 0, 0, 2, 1, 2, 3, 0, 0. We now need to make another quick check earlier on in the circuit code when we're examining the circuit, because okay, edit 12260 C% equals 0. Equals 1. 12265. If C% equals 0, then print there was nothing in position A. Edit 12270. C% equals 0. Edit 12275. If C% equals 0, then print there was nothing in position B. Edit 12280. C% equals 0. C% equals 1. 12285. If C% equals 1, then print. No, if C% equals 0, I'm going to check for 1, then print there was nothing in position C. Run. Okay, load. Test. Exam circuit. That's not good. Oh! Right, so I know what's wrong here. List 12100 to 12300. We don't need to do that, do we? We need to keep everything right. Okay. Edit 12275 needs to go 1 12285 needs to go. 12265 needs to go. Edit 12270. D%. Now we'll call E%. One, two, two, 90. 12290 needs to be next T. 12291. If C% equals 0, then let's just grab all of this. There was nothing in position C. No, nothing in position A. 12292. And we can do this all again. D for position B. 12293. E% equals 0. Nothing in position C. 12294. Go to 3180. Okay, this should work. We just basically want to make sure that if there's nothing in a position, then we remind the player that something could be in that position by telling them there's nothing in that position. That makes sense in my head. Exam circuit. A, B, C. In position B. In position A was a burned resistor, in position B was a charge resistor, in position C was a fried resistor. And then it's saying there was nothing in position B, but there should be something in position B. Get burned resistor from circuit. I was already holding that. You can't be already holding the burned resistor. That's... Ooh, that's weird. So what have we broken? We need this to work. List 1, 2, 3 ones. No, 1, 2, 1, 2, 3, 0, 0. Now we've broken something else that worked, and that's not good news. C, D. Okay, so it didn't print anything for C%. It didn't print anything for E%, it just did it for D%. But we're setting it correctly the same way everything else was. Why is this weird? Don't have audio, so can't follow the thought processes here. Sorry, 69me. There's nothing I can do for that because I can't keep typing everything out that I'm thinking about. Wait, oh dear. I'm going to take this code out that we just did because we don't... Edit 12260. Just take that bit out because if that's causing issues, then let's just make it harder for the player. Because I want this to actually work. I want this to be finished by the end of tonight, basically. Take out these extra bits. One, 2, 2, 9, 1, 1, 2, 2, 9, 2, 1, 2, 2, 9, 3, 1, 2, 2, 9, 4. Edit 1, 2, 2, 9, 0. Next T, go to 3180. Run. Load a save game. Test. Exam circuit. Right. The code for examining the circuit is working. Get burned resistor from a circuit. I took a burned resistor from position A on the circuit. Exam circuit. There you are. With the right tools, I could change the resistors in positions A, B, and C in the circuit. And now position B is gone. Get charred resistor from circuit. Took a charred resistor out. Exam circuit. Now only position C has something in. Get fried resistor from circuit. Took a fried resistor from position C on the circuit. Exam circuit. Okay, now it's working. So we save episode 1. So we can get everything out of the circuit. We can't put anything into the circuit. So we need to do that now. Pen 3. List 1, 2, 3, 0, 0, 2, 1, 3, 0. Where does this code end? Okay, 1, 2, 3, 7, 0. So if I put 1, 2, 4, 0, 0 on here, put in the circuit code. So where is the put code? There it is, 10800. Edit, no, not list. List 10800 to 11099. Put code. There we are. Right, so the put code is very, very short. Okay, 10830, no, 10819, if right string of B string, comma, something, equals in circuit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 4, 6, 8, 10. Yes, B string comma 10 equals in circuit. Then go to 12400. Yeah. Okay, so we now got some put X in circuit. List 12400. 12400 rem put in circuit code. Okay, 12410. B string equals left string B string comma length of B string minus 11. Let's not make the same mistake we did last time. So 11 now, we're taking everything off the end of it, so we just know what's in there. B string. Right. 12410. For T equals 1 to object percent. C percent equals 0. For T equals 1 to object percent. If upper string object string comma T comma 1 equals B string, then C percent equals T. 12420. If current position, if object percent C percent equals current room percent or object if OBJ POS C% equals current run percent, or OBJ POS percent C% equals -1, then go to 12430 else print I could not see a plus lower string B string plus full stop. Go to 3180. Okay, 12430 if a BJPOS percent 1 equals current room percent, or OBJ POS 1 equals -1, then go to 12440 else print I did not have an appropriate tool to do that. Go to 3180, edit 12410 pen 3, list 12400 to 1300. Right, we're doing quick checks now. We're using the put command, so let's put X into Y. And currently I'm just going through all the checks. Is the what is the object number? We're getting that through the same if check as previously, using the for next loop. And 1 2 4 1 5 if C% equals 0, then print I could not find a plus B string plus lower string B string plus, go to 3180. So if C% equals still 0 at the end, then we say, well, I couldn't find it, blah blah blah. I could not see it if it's not in the current room or in your inventory. If you're not carrying the multi-tool, it'll say I didn't have an appropriate tool to put it. Excuse, my goodness, this chair's creaky. Then it would say that you don't have an appropriate tool to put X into the circuit. And now 12440 if C% is less than, the first one is 9. C string is less than 9, or C% is greater than 17, then print that was too big to fit in the circuit. Go to 3180, else go to 12450. Right. So basically that last check there, if C% is less than 9 or bigger than 17, then print that was too big to fit into the circuit, because all of the resistors, including the charged, burned and fried resistors, are object numbers between 9 and 17, from 9 to 17. So if it's not one of that range of numbers, then it's not a resistor. We don't want to be able to put it into the circuit. I don't want to be able to put, for example, the multi-tool into the circuit using the multi-tool. I don't want to be able to put a cardboard box into the circuit using the multi-tool. Or the crowbar that we were using earlier. You can't use the multi-tool to weld a crowbar into the computer circuit, that kind of thing. That's what we're doing with that quick one. 12450 print high. Run. Let's quickly check that bit. If that works, then we've got a working piece of code here, and we can move on from there. Okay, get resistor, and get burned resistor from circuit. Put resistor, burned resistor in circuit. I'm sorry, I didn't understand that. Interesting. Why doesn't that understand that? We've just... The put command should be jump into the put code. Why isn't it jump into the put code? Have we put this in the wrong place? Okay. The parser is at 3180. List 3180 to 4000. Where's the put command? Put. If 10800. So the put command is jumping us to 10800. Okay. Right. Ah. B string equals right string minus 4. Yeah. Because we're taking put off the front with the space. Left of B string equals core. If right string of B string is in circuit, then go to 12400. Otherwise, print. We're going straight over it. That's why. Edit 10811. Run. Load. Test. Oh my goodness, right, let's see. Put crowbar in circuit. Next missing a 12410. Okay. Edit 12411. 12411 next T. Run. Okay, I think we've got it. I think we've cracked it so far. Put crowbar in circuit. I could not find a crowbar in circuit. Could not. What? Why is it saying could not find a crowbar in circuit? That doesn't make sense. List 12400. List 12400 to 1300. Push in circuit. Okay, that doesn't make sense. Right, we've got my first error. Edit 12410. That's B string equals left string B string, comma, length of B string minus 11, print B string. That should work. Why didn't it work? I don't get it. Run, blah, 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 blah. Load, test. Put crowbar in circuit. I wanted to give it an error saying that won't fit. That was too big to fit in the circuit. Right, we're doing all right now. Crowbar. That was too big to fit in the circuit. Get exam box. Get red resistor from box. I was already holding that. No, you weren't already holding the resistor. Drop box. Get red resistor from box. I took a cardboard box. Okay, we have some problems. We know that the resistors to the code is working for getting the resistor. Sorry, the code is working for making sure that we can't put something too big into the circuit. We can't test whether the code is correct for putting a resistor into the circuit because we can't get a resistor out of the cardboard box. Which means we've got a bug. But given that it's past 10 o'clock now, and to be honest with you, I'm making more and more errors, and the silly errors, I'm going to call it a night, guys. And we'll pick this up next week. So I'm going to make a note for myself for next week. Where's my post-it notes? That we need to finish all of this off. So I'm going to make a quick note. Need to finish code to put resistors in circuit. Need to fix code for getting resistors out of the cardboard box. Okay, we will fix this next week. That will be our big project for next week, to fix this code so we can finally finish this major puzzle in the game. Because once we've fixed this major puzzle, then the computer will turn on the ship and we can start moving on with the plot of the game. So, guys, as always, I will save this code now. I'll save it onto the hard drive as well once this is all done. Drives, if not save. Okay, we're at 28k. My goodness. I will make a copy of this available to you as always. Command 3. Right. Where is the where is it? Arbiter. There it is. Oh, come on, guys. Come on, compress. Okay, that is now being uploaded to Dropbox. I will make a copy of that available to you as always. Taking a bit of time tonight to get this to work, isn't it? My goodness. Everything's taking a bit of time tonight. Where's it gone? Arbiter 1. Episode 7. My goodness, we've been doing this for 7 weeks in a row now. Copy Dropbox link. It's uploading. Syncing 2 files. Shouldn't be syncing any files. Should just be working. I'll make a copy of that available to you. That is the code for downloading it. Oh my goodness, guys. Right. That is going to be it for tonight. So thank you so much for watching, guys. And, yeah. I'll see you next week. Same bat time, same bat channel. 8 o'clock GMT. Well, actually, 8 o'clock UK time, whatever time it is in the UK. Whatever, whether we're using daylight or whatever. 8 o'clock UK time next Sunday. We're going to finish this off. We're going to make it work. I hope you've enjoyed it tonight, guys. Thank you for coming along. It has been much appreciated. I'll see you next time. Bye-bye. Has it stopped? No, it hasn't. Everything's going wrong tonight. Good night.